Hello everybody. So today we are going to cover the free body diagrams, and let's start with the definition of those diagrams. So those diagrams are the diagrams used to show the relative magnitude and direction of all forces acting upon an object in a given situation. And I prepared for the class. I drew out the given situation, and this is the inclined plane resting on the ground, and we have an object over here with a mass designated with the letter M. So first of all, and the angle of the inclined plane is theta. So what forces are acting on the subject M? So first of all, the force of gravity going from the center of the body towards the earth, towards the ground, and let's designate this force as the force of gravity, and it's going to be F equals to M times G. And since we are not on the plane level ground, we cannot just assume that the normal force is going up and contrary to the force of gravity, because we have an inclined plane. We have to find the magnitudes of the force of gravity, which is perpendicular to the surface of the plane, and which is parallel to the surface of the plane as well. So first of all, how are we going to do that? We will have to find these magnitude of the force of gravity, which is perpendicular to the surface of the plane, and we will have to find this force that is parallel to the surface of the plane as well. So how are we going to do that? We'll have to find the magnitude of the angles, and let's assume this is a right triangle, so this angle should be equal to 90 degrees, correct? So in the right angle, the sum of all angles has to be equal to 180 degrees. Therefore, the angle, this angle would be equal to 90 minus theta. Now, why do we do that? I don't know if I have to remind you, but I will do, just in case, a little bit of geometry. So, for example, you have two parallel lines. Definitely, I didn't draw them parallel, but let's assume they are. In the drawing like that, this angle would be equal to the opposite and reversed angle over there. So the same, this angle would be equal to that angle. So let's assume this force of gravity is parallel to this line over here. So what does it give us in this case? It gives us this angle, which would be equal 90 minus theta. Okay, we'll find that one assuming this force of gravity perpendicular to the surface of the plane. It has to give us, if it's perpendicular, it has to give us 90 degrees angle right there. And what do we have left? Then it has to be equal to this angle. The sharp angle over here has to be equal to 180. So how do we, the sum of all those angles inside of the triangle has to be equal to 180. So how do we find it? We have to write down the formula, which is x, which is unknown of this angle, plus 90 minus theta plus, and let's put it in parentheses, plus 90 degrees has to be equal 180. So I made the equation so I don't waste your time. I made the equation over here. It's pretty easy, elementary algebra. So we found that this angle x would be equal to theta. Okay, so we found all angles over here inside of the triangle. Now we have to find the magnitude of these vectors perpendicular to the surface of the inclined plane and parallel to the surface of the inclined plane. So how we're going to do that? Probably you will remember using the geometry again, that sine of the angle theta would be equal to the opposite over the hypotenuse. So again, guys, welcome back. Just to save your time, I wrote down that how to figure out the magnitude of the force of gravity vectors, and we had to find again the parallel vector of the force of gravity, which is parallel to the plane, inclined plane, and the perpendicular as well, which is to the surface of the plane. So over here we have the equation where we can find the force of gravity parallel to the vector of the force of gravity, which is parallel to the inclined surface. So how do you do that? Again, you use geometry. The sine of the angle theta would be equal to the opposite side over the hypotenuse. And that's what we have over here. We have the sine of theta angle right here, as I demonstrated you before how I found it. And now we just relate this vector to the same vector up here, and we divide this opposite side of this angle over the hypotenuse, which is mg, which is original force of gravity, which is equal mg. So we take this parallel vector of force of gravity divided by mg, and it would be equal to the sine of theta. Out of that equation, if we multiply both sides by mg, we will find that force of gravity vector of force of gravity parallel to the inclined plane surface would be equal sine of theta times mg. I hope it's clear over here, and you really have to understand how I got over here, and if you don't, again, ask me any questions, and you can re-watch the video, and I try to designate the colors for these vectors over here. Force of gravity perpendicular would be in the red color, and force of gravity parallel to the inclined plane would be kind of grayish color. So again, the same thing I found for the force of gravity, for the vector of force of gravity perpendicular to the surface of the inclined plane, through the cosine of that theta angle right here. Cosine would be the adjacent side, which is this one, over the hypotenuse, which is this thing. And the hypotenuse again is our original force of gravity, which is equal to mg. So this is the adjacent side. This is mg. Force of gravity would be equal to the cosine of theta. Next, again, multiply both sides by mg, and you will find force of gravity perpendicular would be equal to the cosine of theta times mg. That's another thing you really have to pay attention to and understand how I got to this final result. So we found the vectors of the force of gravity, and the normal force, of course, that's another force that would be going perpendicular up to the surface of the plane, and let's give it a kind of gold color and name it Fn, as usually it is. What else? What other forces can we have over here? Friction force. That is very important over here, because if this vector force of gravity parallel vector of force of gravity parallel to the surface of the plane will exceed the force of friction, what would it mean? It would mean that this object will go with no stop, at least on the this plane. Maybe when it will hit the ground, the friction force will increase and it will stop eventually. But if the force of friction is less than the vector of force of gravity parallel to the inclined plane, the object will be moving on this inclined plane. If the friction force, however, let's designate it with a blue line over here like that, blue stripes. If the force of friction will be bigger than the vector of force of gravity parallel to the inclined plane, the object will be not moving, or it will move. It depends on how much force you will apply to the object from this side. It will depend on that. But if you just put the subject, like let's imagine you drop the subject from the top somewhere, or you just put it gently, slightly on the plane, it will not move if the friction force will be greater than the vector of the force of gravity parallel to the inclined plane. What else do we see here? We talked about force of gravity. We talked about the vectors of force of gravity perpendicular parallel to the inclined plane, normal force, and the friction force. I think that's about it, but I would really strongly recommend to review the video, pause it if you need to, and just to see how I got from this angle theta to this angle theta over here, how I found it, and I explained it. I try to explain that over here and through these geometry basics, algebra basics over here. And it's very important to understand how I figure out the equation for the force of gravity, for the vector of force of gravity parallel and perpendicular to the inclined plane. It will be much easier if we plug in the numbers over here, but it's really important also to understand the scheme of this free body diagram, and before you do the numbers, it would be very beneficial for you to know how to deal with all these without the numbers. It will be very, very helpful for you. But anyway, I have one more activity for you, and I will make a separate video, and hopefully if you have any questions, you will bring it to me to the next class. If not, we'll just try to practice the problems, and we will do one more activity in the class, but that's about it for today. Thank you so much for your attention, and have a great rest of your day. Thank you.